My name's Manish. I'm CTO for Hedgehog. And so in this first segment, I want to talk about the open network fabric and how we simplify networking. So if you have to design a modern network, you have a few considerations to think about. I've depicted here a modern GPU training network, right? There's actually two networks, a front end and a back end. You have these servers with usually 10 plus ports that are connected up to your network. And you have to make some choices in terms of how you're going to configure things and what you're going to do there. If it's a little bit too small to read, that's kind of the point. There's a lot of moving parts and a lot of things to get right. We make that a lot simpler at Hedgehog through abstraction. And we have two main abstractions. We have the low-level wiring diagram abstraction, which gives you the ability to describe what topology you've designed to the Hedgehog system. And then we have our operational abstraction that we call VPCs, or virtual private clouds, as Amazon talks about them. I think it's not the best name, but that is what they're known by. And this gives you the ability to partition up your cluster into multiple tenants, connect those tenants together. So when you're using Hedgehog, you have a few steps to go through for your on-prem. So the first piece, the technology is not magic. And so you do have to still design and size your network appropriately. So the question is, you had to ask, first of all, how many networks do you have? After all the converged Ethernet stuff came out, it was, it's easy. You have one spine leaf topology and you're done. With modern AI networks, though, you usually have two networks, one for the back end for the RDMA traffic and one for the front end for everything else. You then also have to then decide, okay, well, what am I connecting to that network? So how many hosts do I have? How many ports? For example, in an AI network, usually you have a NIC per GPU that's going to be running today at about 400 gigabits per second. There's 8 of them in a host if it's the maximum density. So you have 8 ports to your backend network, and then the front end, you usually run 200 gigabit ports off of a smart NIC of some sort. And so that's another 2 ports. Once you have that information, then you get to the fun part, and you get to actually buy some stuff. So you get to go look and say, okay, well, what kind of switches do I want? And how am I going to get all those port capacity in there? And the good news is that this can be daunting. There's a lot of options, but switch hardware vendors would love to help you with this problem because they get to sell you some hardware. So once you have that system built and wired up, you have to specify to Hedgehog how it works. And so you do this through what we call the wiring diagram. And it has a few different moving parts. So these YAML configurations that you see here are the specification of switch configuration and the connections. And so on the left, you see a switch configuration for a DS5000 switch. You specify what model is the switch, what role does it have, spine leaf. You notice that you can very easily set up some AI options. So instead of setting up tons and tons of options around queuing and loss and all that stuff, you can just say, hey, Roki true, Roki QPN, and you get those features for AI networking if you want. And then on the right, you specify the connections between things. So here we have a spine leaf connection, so that's a fabric connection, and then connections, your server-facing connections to your hosts. Everything's in YAML because everything we do is based on the Kubernetes API, and I'll talk a little bit about that next. So the next piece is that you actually have to bring everything up. So Hedgehog itself starts by running on a control node, and that control node is connected to your management network and can speak to all of the switches on the network. And everything, like I said, is done through the Kubernetes API. So why the, oh, there we go, just stalled a little bit. Why the Kubernetes API? So the great thing about Kubernetes API is that you now have a well-known API with a huge ecosystem of tools that you can use to actually configure the system. So for example, if you want role-based access control, you don't have to go and figure out some Hedgehog-specific role-based access control. Kubernetes itself actually has a role-based access control mechanism that you can apply to objects in different ways, and that works just seamlessly with Hedgehog. The other interesting thing about Kubernetes, and we don't think about it too much, it's probably one of the most successful network orchestration platforms out there. Now, you might think, well, wait a minute, isn't Kubernetes there to deploy applications and manage them? Yes, but when you do that, the overlay networks that are run in these CNIs are actually managing your overlay network in that situation. And so it's it's a very, very popular network orchestration system. What we've done is add some CRDs to extend it so that it can configure the physical network as well. So you take that wiring diagram, you feed it into that Kubernetes API, and what happens then is that the system is going to use zero-touch provisioning and boot and install the network operating system on all your switches. It'll handle upgrades and lifecycle issues around those switches, and it configures an agent on each of those switches so that it can enforce the configuration that you've specified through our APIs. So that's the low-level API. Now, you still have to actually have your cluster tenants. So you're not done just once the network comes up. You actually have to do something. If you don't have something like Hedgehog, then multi-tenancy becomes an issue. Generally, in a large cluster, there are times where you want to partition that thing up. And you got to figure out how I'm going to do that. So are you going to have a VRF per tenant? Are you going to run BGP with EVPN, with L2 VXLAN, maybe L3 VXLAN, what VLAN setups? There's a lot of configuration that goes into those tenants. And after you've configured that, then you have to figure out, okay, how am I going to peer those tenants together? What routes am I going to leak? What route maps do I need so I don't leak the wrong routes? There's a lot of stuff going on here. And it's all manual configuration under the hood there to do that. Make sure you don't make any mistakes as those things change, because you can otherwise then connect tenants that shouldn't be connected and have problems with that. So multi-tenancy with Hedgehog, essentially now we have a VPC abstraction. So on the left, you can see this YAML, which is which describes a VPC. And so it has all the stuff that you would think about having for a network. So you can configure DHCP, your IP ranges, your host routes, and so on. We have different modes of operation, which is actually important. You can operate a VPC in L2 mode, which creates a layer 2 network across the overlay network, or an L3 mode. L3 mode is important because if you're building a higher speed network with, say, Broadcom's Tomahawk 5 chipset, doesn't support L2 VNI. So you can use L3 VNI. And then you just say which hosts are on which VPCs through those attachments. When you do that, everything else is configured under the hood. So we configure BGP EVPN, we configure the VLANs, we configure the route leaks, everything else that you need to get those tenants up and running. Now, it's not useful to have usually a tenant that just talks to itself. You usually want to talk to something else as well. And so here you have peering. So I've shown a peering object here on the left. This is a simple peering object. I'm not going to, for time reasons, I'm not going to go into the details of the additional permit and deny stuff that you can have there based on subnets. What we do here, when you push that peering object, we will now configure route leaks between the VPCs. And those route leaks now allow VPC1 to communicate with VPC2 and vice versa on the IP addresses that were leaked. Not trivial to do correctly. It's very easy to leak the wrong routes and get more connectivity. So all the route maps and ACLs and everything to make this work are done automatically. I'm pointing out this route leaking too because it'll become important in how the gateway actually integrates with the product. But for now, I'm going to hand it off to founder and chief architect Sergey Lukyanov to run a demo and show you how all this works. And then we'll move on to the new material, which is Gateway.
Okay. Sounds good. So we'll start with taking a quick look on the topology that we're using for it. So for the demo, just to keep it simple, we have 3 switches. Those are Celestica DS5000, 800 gigabit switches. One as a spine, 2 the leaves. The actual topology doesn't make a lot of a difference for the demo, but it's kind of more or less regular setup. And we have a gateway connected to the spine that we will talk in the second part of the demo. But for now, we will take a look on the server 1 and server 4, which are connected to VPC1 and VPC2. We have a different subnets. So I'll go into here, and we'll have the example of the VPC. So the VPC1 here does have a subnet of 1050.10/24, and like each VPC can consist of multiple subnets. Each of them are named some way, and you can define it. So, for example, subnet 01 is a name for the one that's going to be using in the demo, and have a VLAN attached to it. So that's how the servers, the tenant servers, are getting attached to the VPC. And then we provide a bunch of out-of-the-box functionality for the VPCs, like out-of-the-box DHCP, and we can do the DHCP relay for if you already have your own DHCP server, and we provide passing like multiple customizations to like how DHCP will work, like time servers, NTP servers, custom routes, all the stuff that you expect from DHCP. And the benefit of that, you get all the DHCP functionality out of the box, despite the very complicated multi-tenancy model. So you don't need to solve it on your own. So now, if we look at the probably back and on a scan here. So what I want is to just ping between the servers, and we can go to the environment, and you can see like on top on server 1 I have 1051.2, and here on the bottom I have 1052.2 IP address on the server 4. So if we'll just try to, sure, it will disconnect on the demo. Yeah, if we would try to ping this IP address, and I just pass in a couple arguments to do more pings and some payload in them, so it will be more visible on the graphs. It's not working because we don't have a peering between the VPCs. So now, if we take a quick look on the peering between the VPCs, VPC1 and VPC2, the minimal version of it is very simple. You just need to specify the pair of VPCs that you want to be able to talk to each other. And we do allow to specify a little bit more precision. You can say like which exact subnets can talk to other subnets between the two VPCs. And we have more granularity using the gateway, which will be second part of the demo. So let's apply it now. So we just apply the Kubernetes object. You can use like one of the benefits of using Kubernetes is that you have all of the tools in a very good shape for Kubernetes, because like a lot of people around the world using it to run applications. So you have all your GitOps, all your like configuration tree detection, all the tooling is very good tuned towards it. And here, basically, by applying that, it is using a very simple YAML. Under the hood, we have a fabric controller that takes this object and converts it to the set of configuration changes that needs to be applied in the switches, and switches running the edge, and that's basically polling the API and looking into what actual change need to be applied. So it detects configuration drifts, it returns some data on the monitoring and introspection from the switches and things like that. So now, if we would get back to the server, you can see we have a ping running right now. So like in one thing I want to demonstrate, which Manish was mentioning, like how it's implemented under the hood. So if we go on a switch, then we can just take a look on the routes in the VREF, and like each VPC is basically the VREF, a network instance on a switch. So if we just go to look at the routes in VPC1, you can see that we have some routes from the VPC itself. Like we know about the host like 12/32 IP address that we had on the server 1. And then you can see that about like a minute ago, like a minute and 4 seconds ago, we got another couple of IP addresses, IP routes from the BGP. That's exactly when I created the peering configuration in our API. It reconfigured the switches to actually leak routes between the VREFs. So now we have some routes from the second VPC leaked into the VREF of the first VPC. That's how the connectivity between them is established. And just to demonstrate it, like another thing, we can go to the Grafana dashboard. It's just a Grafana cloud. We support collecting and exporting metrics, basically all the metrics from the switches, our control node, a lot of insights like counters, QDAPs, basically all you can think about like over like interesting and important information from the switches. We do support like pushing it to the Prometheus compatible APIs. And we do collect all the logs as well and push it into logging compatible APIs. So essentially, if you have something that's compatible with LGTM on API level, you can use it. And here, just to kind of demonstrate a little bit that we use like switches to do that, we have those switches, they've been shown in a diagram, attached to different leaves. So essentially, this graph is from the spine, and we're looking at the two downlinks from the spines to the leaves, and we can see that some traffic going there. That's why we see that basically the same numbers for the 2 ports on the spine, because two different switches leaf switches are attached there. And that's kind of indication of that we're not using gateway. We just directly peered on the switches. And that's it for the first part of the demo.
Great. Thanks. One thing I want to mention, by the way, about the Grafana Cloud and the dashboards, one of the cool things about the API is you just have a small YAML file that gives you your credentials to your stack, your Grafana stack, and it connects and then automatically starts sending all the data to either Grafana Cloud or whatever your on-prem stack is. So you don't actually need to do a lot of switch by switch configuration or anything to actually collect the data in a centralized way. It's also turnkey.